radio transmission. So this is the whole electromagnetic spectrum, and every part of that spectrum is used for communication. So in radio transmission, we will talk about various bands, all the spectrum. So coming to RF, that is the radio frequency. What is frequency? The number of oscillations per second. So we are talking about electromagnetic waves transmission, and here the range is from 3 kilohertz to 300 gigahertz. That is the radio frequency is any of the electromagnetic waves frequency that lie in the range extending from 3 kilohertz to 300 gigahertz. So these waves can even jump the mountains. They can travel long distances. If you have some building, they can even penetrate the buildings. This RF or RF mode radio frequency is used widely for communication, information exchange purposes. It can be inside your home, it can be outside. And the important part is this radio frequency waves, they are omnidirectional. Omni means in the direction everywhere, 360-degree direction. Travel in all the direction, can be sent in all the directions and can be taken, received in all the directions. Bidirectional means two direction, unidirectional means one direction. So this is if this is transmitter, we have a receiver. So the transmitter and receiver, we don't need to align them linearly. That is, they don't need to be carefully aligned physically, because both of them are omnidirectional. Radio waves and other waves which we are going to talk about, the properties are frequency dependent. Frequency dependent, you know the formula. This wavelength into frequency is the speed of light. Frequency, wavelength, they are interdependent, inversely proportional. So that is how we will talk about frequency, but we are talking about lambda also, the wavelength also, because they are inversely proportional. C is a constant. But we will, in these terms, we will only talk about the frequency. So these waves are frequency dependent. Now the low frequency and high frequency. At low frequency, the radio waves, they pass through obstacles easily. Low frequency means the wavelength is quite high. Wavelength is from the center line, the peak of that wave. So it can even go up to or jump up to these different mountains. So power of the wireless transmission, it reduces with the square of distance. Power of that wave. So power and this distance, they are directly related. Okay. So power and wireless, this transmission reduces with square of distance. Now this is a relation of power. Now I'll show you the relationship after this, the relationship of the path loss. That I'll show you just now. But for time being, the power is computed like this. We have the distance directly proportional and the lambda in the inverse. So what I'm saying is, power falls sharply with distance. That is, the factor is 1 by r square. R is the distance, right? So power will definitely reduce. Attenuation will take place. The power will reduce. And this is not only true with the radio waves. It will happen with every wave. There will be some attenuation, and there is a power relation. The long wave length, that is the low frequency, they have less loss. And these short wave I am showing you, these are high frequency, they have more loss. So the attenuation, we will call it as path loss. Attenuation is the loss of energy, loss of, you can say, the content, so that we need to reboost it somewhere. Okay, coming to the high frequencies. At high frequencies, these radio waves, they almost travel in straight lines, and they also bounce of the obstacles. That is, if some obstacle are there, they will strike the obstacle and they will bounce off. So this is therefore the high frequency radios, these waves are also absorbed by rain, water, and also obstacles. So the high frequency, the low frequency, they are not that much absorbed by rain and obstacles because the wavelengths are higher. So high frequency radio waves, they are absorbed by rains and obstacles. Now this is the relationship of path loss. Now path loss is inversely proportional to the distance. So I showed you that how does this power reduces with the factor of 1 by r square. So this is a path loss, and normally the power etc. we try to compute in the form of ratio, and then we can convert this all into decibels. We're taking logs. That is not the discussion here. but just for the sake of completion, we have d as a distance, f as frequency, lambda as wavelength, and c of course the speed of light. Now with fiber, coaxial cable or twisted pair, the attenuation, that is the signal drop, this also drops by the same fraction per unit distance. For example, the twisted pair, for 100 meter, there will be a loss of 20 dB. 20 dB it will lose. With radio, the signal will drop by the same fraction as the distance doubles. I told you about the ratio, or you can the factor multiplied is the you can say a reciprocal of the distance. So it is 6 dB per doubling in the free space. Free space is what the space we see. So this is the difference between the twisted pair and the free space. How does the attenuation take place? So this means that the radio waves, they can travel long distances, and therefore if two people are talking, they are sending the radio waves, the interference will take place. That is, if the constructive interference can also be there, destructive can also be there. So the destructive interference will say attenuate both the signals. So therefore, this is the reason why the government actually tightly regulate the use of radio transmitters. Everyone cannot use these range of frequencies, right? Because of the interference. If you talk, other person is talking, there will be interference. So the government has to come in between, and they have to regulate the use of these radio transmitters. This is the reason. The reason is interference. Remember? In this radio transmission, as I said, from 3 kHz to 300 GHz, there are different bands being defined. So these are the VLF, LF, MF, HF, VHF, UHF, SHF and EHF. Now these are very low frequency, and medium frequency. Then we have others also, high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency. Now as I said, it starts from, as we know that it is 3 kHz to 300 GHz. So when you talk about VLF, we are talking about 3 kHz to 30 kHz. LF, we are talking about 30 kHz to 300 kHz. MF, we are talking about 300 kHz to 3 MHz. Okay, this is how the wavelength will also change. This I am talking about the frequencies. So in this VLF, LF and MF band, the radio waves, they follow the ground. That is, they will take the path or the shape of the ground. This is how they travel, near the ground. And for example, if you see here in the picture, the AM radio, amplitude modulation, this radio was broadcasting, this uses the MF band. And if you talk about FM radio, it will use the VHF band. So this is how the FM is quite clearer than this AM radio transmission. This AM part, that is called the MF part. So radio waves in these parts, they pass through building quite easily. That is why inside house also, you can easily tune into your favorite radio station. Okay, outdoors, indoors, both. But the problem is these three bands which we just talked about, or the near band for data communication, is the low bandwidth. The bandwidth is very less. Bandwidth is nothing but the difference of the frequency. Now if you go above the HF and VHF band, very high, this high frequency and very high frequency, here the ground waves are actually absorbed by the earth. As I told you, when the frequency will increase, the wavelength will decrease, and that will be bound to be absorbed by earth. But there are certain waves that may reach the ionosphere. Ionosphere is around 100 to 500 kilometers. That is the layer of our earth atmosphere. So there are free ions. Now these free ions, there is a, when the wave goes, or there is a technique or a physical phenomena called refraction. So these, some of the rays, they come back, they are refracted back. This ionosphere plays a very important role in this. So I am talking about the HF band and VHF band. Ionosphere, so this goes, and as I said, that there is a refraction and other physical activities also taking place. So this, they come back to earth, or they are sent back to the earth by the ionosphere, because the ionosphere is all about ions, free ions. So this refraction, that is how we can communicate. For example, the hams, you might be knowing about it, amateur radio operators, hams, they use this band to talk a large distance, long distance, just because ionosphere is there. And also we have HF and VHF. These bands are used normally by the military for communication. If you're going into the field or into military, you must be knowing, or you should know HF and VHF.